Hello, my dear students. Welcome to IKSR chemistry classes. In this video, we will discuss an important topic of inorganic chemistry, and it is electron transfer reactions. Questions related to this chapter are asked frequently in general examinations as well as various competitive examinations such as UGC, CSIR, NET and GATE examinations. First of all, let us see what are electron transfer reactions. The chemical reactions in which electron is transferred from one atomic, molecular or ionic species to another atomic, molecular or ionic species are called electron transfer reactions. In nutshell, we can say that the chemical reactions in which electron is transferred from one species to another species are called electron transfer reactions or redox reactions. Let us see an example of electron transfer reaction. When sodium and chlorine atoms are brought in contact with each other, an electron is transferred from sodium atom to chlorine atom. As a result, sodium is oxidized to Na plus ion and Cl is reduced to Cl minus ion. Here Cl, which gains electron, which oxidizes sodium, acts as oxidant or oxidizing agent. On the other hand, sodium atom, which reduces chlorine and loses electron, acts as reductant or reducing agent. Electron transfer reactions in coordination compounds. The electron transfer reactions in coordination compounds may take place by two different mechanisms, and these are given below. Electron transfer reaction by outer sphere mechanism, and the second one is electron transfer reaction by inner sphere mechanism. In this video, we will discuss electron transfer reaction in coordination compounds by outer sphere mechanism. When both the reacting complexes or reactant complexes taking part in an electron transfer reaction are inert. If both the reacting complexes taking part in an electron transfer reaction are inert, the ligand exchange reactions take place much more slowly than they participate in electron transfer reaction. It means when the reacting complexes taking part in an electron transfer reaction are inert, they undergo electron transfer reaction much more rapidly than ligand substitution reaction. Such electron transfer reactions don't lead to any net chemical reaction, and these are called direct electron transfer reaction, electron exchange reaction, or electron transfer reaction by outer sphere mechanism. It means the outer sphere mechanism is applicable when the reacting complexes taking part in an electron transfer reaction are inert and they cannot exchange ligand. The coordination spheres of both the reacting complexes remain intact, unaffected during such electron transfer reaction. It means the coordination sphere of reacting complexes are not affected. They remain intact during electron transfer reaction by outer sphere mechanism. Only the oxidation state of metal ions involved changes as a result of electron transfer reaction. If the electron transfer reaction takes place by outer sphere mechanism, the coordination spheres of two reacting complexes remain intact. There is no net chemical reaction. Only the oxidation state of metal ions involved changes as a result of electron transfer reaction. A typical example of such electron transfer reaction, as studied by isotope labeling experiment, is given below. This is FeCN whole 6 4 minus, in which the oxidation number of iron is +2. This is another complex FeCN whole 6 3 minus ferricyanide, in which the oxidation state of iron is +3. This iron atom is labeled with unique radioisotope. This is the complex compound having 3d6 electronic configuration of Fe2 plus ion. It is low spin and inert complex, while FeCN whole 6 3 minus has +3 oxidation state of iron with electronic configuration 3d5. It is also a low spin and inert complex, and it is due to a strong ligand field created by Cn minus ions. An electron is transferred when these two complex compounds are brought together, are brought in contact with each other. An electron is transferred from this complex FeCN whole 6 4 minus to FeCN whole 6 3 minus. This electron transfer reaction takes place. Here Fe triple plus is reduced to unlabeled. Fe triple plus is reduced to Fe double plus, and hence FeCN whole 6 4 minus acts as reducing agent or reductant. On the other hand, the labeled Fe2 plus ion is oxidized to labeled Fe triple plus ion because it loses one electron. This complex compound is oxidized, and hence its partner FeCN whole 6 triple minus acts as oxidant or oxidizing agent. This is an electron transfer reaction in which the coordination spheres of both the reacting complexes remain intact. There is no change in its coordination number. Coordination sphere of both the reacting complexes remain intact. Only the oxidation state of metal ion involved changes during electron transfer. Labeled Fe is oxidized from +2 to +3 state, while unlabeled or non-labeled iron atom is reduced from +3 to +2. This electron transfer reaction takes place by outer sphere mechanism, which does not lead to any net chemical change. The reactants and the products are almost similar. The coordination spheres of both the reacting complexes remain intact. Only the oxidation state of metal ion involved changes during electron transfer. Kinetics of electron transfer reaction by outer sphere mechanism. The electron transfer reaction, which takes place through outer sphere mechanism, follows second order kinetics. The electron transfer reaction following outer sphere mechanism follows second order kinetics. For example, the given reaction The reaction under consideration on the previous slide follows second order kinetics. FeCN whole 6 4 minus ion which acts as reductant, while FeCN whole 6 triple minus which acts as oxidant. It must be noted that 4 minus is retained within coordination sphere because this is not coordination sphere. It represents molar concentration. 4 minus charge is written here within square brackets. Here the square brackets don't represent coordination sphere. The square brackets represent molar concentration. This reaction is first order with respect to reductant and first order with respect to oxidant, and therefore the overall order of reaction is 2. Thus, we can say that the electron transfer reaction which follows outer sphere mechanism, which takes place through outer sphere mechanism, follows second order kinetics. First order with respect to reductant and first order with respect to oxidant, and hence the overall order of reaction is 2. Now, the mechanism of electron transfer reaction by outer sphere mechanism. The electron spin resonance spectral studies indicate that the valence electrons of the central metal ion of a coordination compound spend some time on the ligands also. It has been supported by hyperfine structure of ESR signal in the complex IRCl6 2 minus ion. The ESR signal of IRCl6 2 minus exhibits hyperfine structure, which has been explained by saying that the valence electrons of the central metal ion spend some time on ligands also. Hence, the electron transfer may take place from the outside of the ligands of one coordination sphere to the outside of the ligands of another coordination sphere by hopping process. The hopping word has been derived from the motion of frog. The frog jumps from one place to another place, and this jumping is also called hopping. The ESR spectral studies suggest that the electrons of central metal ion of a complex compound spend some time on ligands also, and therefore the transfer of electron from outside the ligands of one coordination sphere to the outside of the ligands of another coordination sphere may take place by hopping process. This is why it is called electron transfer reaction by outer sphere mechanism. This is FeCN whole 6 4 minus ion having labeled iron atom in +2 oxidation state. And this is FeCN whole 6 triple minus ion having non-labeled iron atom in +3 oxidation state. The valence electron of Fe2 plus ion spends some time on Cn minus ion also, and hence the electron jumps from Fe2 plus to Cn minus, and then from Cn minus to Cn minus of this complex, and from this Cn minus to Fe triple plus ion. The electron transfer reaction takes place from Fe2 plus to Fe triple plus by hopping process. Fe2 plus to Cn minus to another Cn minus, and from Cn minus to Fe triple plus. As a result of this electron transfer, labeled Fe2 plus ion is oxidized to Fe triple plus ion, while non-labeled Fe triple plus ion is reduced to Fe double plus ion, and the charge on the coordination sphere also changes accordingly. Here 4 minus charge and 3 minus. In this case, the charge is 3 minus, 3 plus, and 6 minus is 3 minus. In this case, 2 plus and 6 minus on Cn minus ions, overall 4 minus. It is obvious that the electron jumps from the central metal ion of one complex to the central metal ion of another complex through the intervening ligands as illustrated in the sidewise figure. Electron jumps from the central metal ion of one complex to the central metal ion of another complex through the intervening Cn minus ion ligands. Kinetics and thermodynamics of electron transfer reaction by outer sphere mechanism. We have already seen that the electron transfer reaction under consideration, which follows second order kinetics, takes place rapidly. The electron transfer reaction taking place through outer sphere mechanism follows second order kinetics, and it takes place quite rapidly with velocity constant k is equal to 10 to the power 5 liter per mole per second. There is no enthalpy change and no Gibbs energy change during the reaction because the reactant and the products are identical and hence have the same energy. In electron transfer reaction by outer sphere mechanism, the reactant and the product are generally identical, having the same amount of energy, and hence such reactions don't involve any change in enthalpy or Gibbs energy. Hence, it is expected that the activation energy of the reaction is zero. But it is not true. The electron transfer reactions proceeding through outer sphere mechanism have some significant activation energy. The energy profile of electron transfer reaction by outer sphere mechanism is given below. The plot of Gibbs energy versus the reaction coordinate of electron transfer reaction by outer sphere mechanism has symmetrical shape as shown in the figure on the next slide. The plot of Gibbs energy versus reaction coordinate for electron transfer reaction by outer sphere mechanism has symmetrical shape, which has been represented on the next slide. This is due to the symmetrical shape of the energy profile is due to the fact that the reactants and products of such reactions are similar and they have same energy. FeCN whole 6 4 minus having labeled Fe atom in +2 oxidation state, FeCN whole 6 triple minus having non-labeled iron atom. These are reactants, and electron transfer takes place from labeled Fe2 plus ion to non-labeled Fe triple plus ion. This is the transition state, and as a result of this electron transfer, the labeled iron atom is oxidized to Fe triple plus ion, while non-labeled iron atom is reduced to Fe2 plus ion. Let us compare the reactants and products. The reactants and products are identical. Only the oxidation state of metals have changed during electron transfer. and hence the reactants and the products have the same Gibbs energy. There is no change in Gibbs energy during electron transfer reaction. During this electron transfer reaction, which follows outer sphere mechanism, despite it, the reaction involves some significant transition. The reaction involves some significant Gibbs energy of activation, which is denoted by delta GH. And this significant Gibbs energy of activation depends upon various factors. There are various factors which contribute to the Gibbs energy of activation delta GH of electron transfer reaction by outer sphere mechanism. The reactants and products of an electron transfer reaction which follows outer sphere mechanism have the same energy, and hence the Gibbs energy change for the reaction is zero. The enthalpy change of reaction is also zero. But this reaction involves some Gibbs energy of activation, which determines the rate of reaction. Greater the value of delta GH, slower will be the electron transfer reaction. And there are various factors which affect the value of delta GH, that is Gibbs energy of activation, and that is rate of reaction. There are various factors which affect delta GH and the rate of electron transfer reaction taking place by outer sphere mechanism, and these factors will be discussed in lecture number 2 of this topic. Thank you for watching the video with concentration. Please like, share and subscribe it. Thank you again.